my channel. My name is M.R.E.ngineering and today I'm going to talk about electrical circuits and their components in a typical car. Maybe you know that there are two types of electricity. AC type that fluctuates in direction and its magnitude is expressed in a kind of mean voltage or current known as RMS, like household electricity of 120 or 220 volts. Another type of electricity is DC type that is mainly produced by battery and battery chargers, and it has a direct and constant magnitude and direction. And of course, most of the cars work with a nominal 12-volt DC voltage. But when the electrical current starts to travel from positive side of the battery, it seeks a path to the negative side to complete the circuit. Designers put the switch and consumers in series or parallel configurations to use and control that electrical current. In this diagram, you can see a very simple circuit that can be used, for example, for tail lights of a car. As you can see, if one of the lights in this circuit burns out, still there's a path for the current to go to the negative side that is also known as the ground, and I talk about that in the following. Also, consider that each lamp in this circuit is a load, so the current can't freely flow to the negative. In other words, there's a resistance in the circuit. Now, imagine that a short to the negative or the ground happens for this circuit. In this case, the current can flow to the negative side without any resistance, so a high current can flow in the circuit. This high current is very dangerous. First, it starts to heat up the wires that it is flowing through, and then with more and more heat, it can result in fusion or even a fire. But if the circuit continues to pass this high current, it can result in severe damage to the battery and even an explosion. To prevent these damage to the wirings and components, every circuit needs to have at least one fusible link in that, so it breaks and opens when a short to the negative side happens to that circuit. Also, always to protect the battery, there is a single or a few main fuses with high amperage capacity just after the battery. But our circuit is still mature. Components that demand high currents require larger diameter wires in their circuits, but you cannot use these high current wires in a circuit that a switch is controlling that in series. The reason is very simple. It's because the cost of routing these larger diameter wires to the switch and then to the consumers increases, and also sparks and arcings that these high currents make when the switch opens and closes will damage the contact points of that switch. And remember that many of these switches are located inside the sensitive ECUs. Now, to solve these problems, we can isolate the switch from the main circuit and use thin wires to connect that to a relay, that when this relay is activated by the switch, the coil inside that makes a magnetic field that connects an internal switch for the main circuit. So this relay makes our design more optimum and efficient, and our circuit in simplest form turns into this configuration. In this circuit, the switch can be a simple heater switch, a multifunction headlight switch, or a main ignition switch for starting the car. For the starting system, the relay is mounted on the starting motor and is known as a starter solenoid. About the starting system, I'll have another video to talk about that, but if you can't find the starting motor on the engine, you can see that there are two wires are connected to that. The thin wire from ignition switch and for commanding the start, and the thicker one that is connected directly to the battery to draw a high current during starting. But most of the relays are compacted with the fuses in a few junction or power distribution boxes for sake of simplicity and saving wirings. These boxes are located inside the cabin, under the dash, or in the trunk, or under the hood next to the battery, or maybe other places on the vehicle. Also, you can find relays or fuses out of these boxes near the consumers, like some air conditioning system or radiator fans. But if they are contained into a box, usually their usage and rating are marked on the cover of that box. Now I want to talk about negative side of the connections or ground side of the circuits. We can say that on all the vehicles, when we are talking about the ground, we are talking about negative post of the battery with zero reference voltage. And remember that almost all the body of the car is connected to the ground. So when we want to connect end of each circuit to the negative or ground, we don't need to connect that directly to the negative post of the battery, and just connecting that to the bare metals of the body is enough. This ground connection is done by connecting ground straps between the battery and the body. Also, since the powertrain is insulated from the body by rubber mounts or bushings, and they are kind of insulators, so at least one ground strap is required to connect the powertrain to the negative. Okay, these were just very simple fundamentals for circuits, but by understanding these fundamentals, you can have a general idea about the whole electrical systems and circuits that are used on your car. On the car and in practice, a circuit can be consisted of many of these simple circuits, and the whole electrical system is intertwined wires, fuses and relays that are connected to each other in series or parallel circuits to have that desired output. And remember that a circuit can have many fuses and relays on that, and also a fuse or relay can be used by multiple circuits. In fact, the creativity of designers is very critical for simplicity and effectiveness of the circuits. In the factories, to save the cost of production and optimize occupied space by the wires, designers put the wires side by side and route them together. These sets of wires, if get grouped together, are known as wire harness. In a car, there are a few main and big wiring harnesses, and they are used in engine compartment, under the dash, on the floor, and maybe under the roof. Also in the cars, there are simple wiring harnesses that are used to feed the electrical power to components that are far or need a special routing. An example is lighting system that usually has a simple wiring harness. Also, in some cases, high current wires are routed separately to reduce electromagnetic noise on other sensitive circuits. This noise returns to a scientific fact that states that when a current is passing through a wire, causes a magnetic field around that wire, and magnitude of this magnetic field is proportional to magnitude of the current that is passing through that wire, and change of this magnetic field can induce a current in the conductors around that wire, and this unwanted current in this case is known as electromagnetic noise. Well, I don't want to confuse you and go beyond joule tolerances. Now I come back to our main subject. Also, manufacturers use flexible conduits over these wire harnesses to protect them against impacts and abrasion, and also at the end of the wires there are connectors to connect them to the components and junction blocks. But again, talking about these connectors, their design and types is not subject of this video. Also, among the wires in the wire harnesses, there are some wires that are used to transfer data between modules over some data bus networks. In a car, networks are used to connect the modules and computers to each other, and since a major part of controls and circuits are related to these computers, that using solid-state electronics can reduce a massive amount of wires and increase the speed and reliability of the systems. For example, for a high-speed CAN network, these wires are coupled and twisted to each other to reduce electromagnetic interference. About the networks and different protocols that are used in a car, I'll make a few videos in the future, but those videos are very technical and don't fit the owners. Also, manufacturers prepare some manuals that show the whole circuits, components, modules, pin number of connectors, and even color of the wires for each system. And of course, using these manuals require experience and training, but a qualified technician can use them easily to follow the circuits and diagnose and fix the electrical problems. Now, I want to review the electrical systems and their operation from the time you sit in the car and start to move until you stop and turn it off. But please note that due to difference between designs and level of technologies, systems and circuits can vary from car to car and model to model. But I try to talk about them in general and most common types that are used today in automotive industry. When the car is off and even the key is out of the car, the battery voltage is present and can be used. Some systems and components use this electrical power when the car is off and is resting in parking state. One of these systems is security system that is vigilant for any intrusion, and also engine control module, like many other modules, is receiving constant battery voltage to retain some data in memory and also perform some leakage tests and calibrations even when the car is off. Normally, a typical car consumes about 20 to 50 milliamp current during parking time. Now, when you are sitting in the car and before you insert the key inside of the ignition switch, some systems are active and can be operated. These systems are like interior lighting, headlights, flashers, and the horn. In modern cars, these systems get activated by the relays that are controlled by an ECU called Main Body Control Module, or BCM. Now we can say that these systems don't have the ignition switch and their circuits, but they are always protected by at least one fusible link after the battery. Then, when you insert the key inside of the ignition switch and turn it to ACC position, some accessory systems like clock, radio, and lighter get activated, and also in some cars, systems like seats, air conditioning, and even windshield wipers are incorporated into this ignition switch position. Next step, when you turn the ignition switch, is on position, where you can hear a noise from the fuel pump indicating that it has activated to get primed. I jump this key position to talk about that after the starting. Then, when you turn the ignition switch to the end position, that is protected by a spring so that the key doesn't stay there. When you release that, electrical power is fed to a starter relay to crank the engine. And at the same time, engine control module receives ignition feed to activate the fuel pump relay and drivers for injectors and ignition coils only if it receives permission from the security system and signals indicating that the crankshaft is rotating by the starter. In this condition, if the air, fuel, and sparks be present, car starts and keeps running. Now, you can release the ignition key and it returns to the run position and the starter disengages from the flywheel or flex plate. But engine continues to run as long as the ECM receives crankshaft rotation signals and enough air, fuel, and sparks are provided. Now we can say that in run position, almost all the electrical systems and components of the car are active and are ready to be used. In this state, if you turn the ignition key back to ACC position, ignition feed for engine control module terminates and all the relays and drivers of the engine will shut down and car turns off. Now you can understand that how much role of the engine control module or powertrain control module, known as ECM or PCM, is critical for starting and running the engine. But the ECM is not the only module that is used in a modern car. As I said, there's at least one network that the ECM is working on that. And if there's more than one network used in a car, always the ECM works on the high-speed one. For designs that more than one network used in a car, usually a module works as the gateway to translate different messages between different data bus networks for optimum communication. Also in the cabin, most of the accessories except multimedia work on low or medium speed networks. Some designs use a single wired data bus for low speed networks. So, for example, for an exterior mirror that doesn't have any camera or radar on that, many functions can be accomplished using just 3 wires. A battery positive feed that is provided by a relay that is controlled by a module, a constant ground connection, and a single wired communication line. These 3 wires are connected to a slave module inside the mirror to accomplish the commands that are sent from a master module. I think going further more into details of electrical systems in this video is a big mistake and makes you exhausted. I explain different electrical systems in different and separate videos, and if you follow my channel, you can watch them in the future. I hope that this video was useful and informative for you and worth the precious time that you spend for watching that. Please subscribe to my channel if you like and press the bell icon to be notified if I have a new video on my channel. Bye.